Hello, everyone. In this video, we're going to continue our work from section 3.6 on area and average values by computing the average value of a function. So before looking at the example, I just want to recall what average value means in terms of our computations here. So if we have, say, a graph from or on the interval from a to b, let's call it f of x. Then to compute the average value of the function f of x on the interval a to b, what essentially we're doing is to compute on average what do we expect the value of f of x to be. So to do that, we find the total area under that curve on that interval, and then divide by the length of the curve, or not length of the curve, but rather that length of that interval. So the length of the interval is b minus a, and you might want to take a moment to pause the video and consider why that is. Essentially what happens here is where you measure how long or how high b is, subtract the value of a, and that tells us that distance between them. So then the average value of f would be the overall integral of f from a to b, and then divide by that size of the interval. So if we want to write this down here, we have the average value of a function f of x on the interval a to b is, well, we compute that integral from a to b of f of x, and then we divide by the length of b minus a, or that length of the interval. Another way to write this, which is more common, is to multiply by 1 over b minus a. So it's the same computation, but one way of saying divide by b minus a, another way is saying multiply by 1 over b minus a. So here is that average value of a function. So you might want to just box this in your notes for later reference. All right, so now let's look at this example. So example 5 says, during a 9-hour workday, the production rate at time t hours after the start of a shift was given by the function r of t equals 5 plus root t cars per hour. Find the average hourly production rate. So what we're given here is this function that tells us the amount of cars per hour that were produced. So if we are looking at a 9-hour workday, then our interval that we're looking at this production rate over is the interval from 0 to 9. So 9 total hours starting at 0, 9 hours later. So to find that hourly production rate, we want to take the integral from 0 to 9 of our function r of t, in this case dt, and then multiply that by 1 over 9 minus 0. So go ahead and set up that integral. And then what I'd like you to do is pause the video to compute that integral. Compute that integral, multiply by 1 over 9, and then we'll check our work. All right, so when you're ready, let's continue together. So then this integral becomes the integral of 1 over 9 times, so we'll find that antiderivative, so 5t. And now square root of t, that's the same thing as saying t to the 1/4, or 1/2 rather. So if we're finding the antiderivative, we'd have t to the 3/2 over 3 over 2. And if you want, another way of writing that would be t to the 3 over 2 times 2 over 3. Now that's going to be evaluated from 0 to 9. So then we can evaluate that integral. So we first plug in 9, so 5 times 9 plus 2 times 9 over 3. And that's 9 to the 3 over 2. Then we're going to subtract 5 times 0 plus 2 times 0, which all just becomes 0. Well, in that last term becomes 0. So this becomes 1 over 9 times 9 times 5 is 45 plus 9 to the 3 over 2 is 27. So we get 2 times 27 all over 3. So we can further simplify here. So we get 1/9 times 45 plus, well, 27 divided by 3 is just 9 here. So this simplifies to be 9. So 2 times 9 is 18. So we get plus 18. So now I can bring the 1/9 into each term if we'd like. So 45 over 9 is going to give us 5. Plus 18 over 9 is going to give us 2. So we get 5 plus 2, which is 7. And so we want to put some units on this because we want to find the average hourly production rate. So the average hourly production rate rather is this rate, or is the unit on R of T. So it'd be cars per hour. So on average, on a 9-hour shift, there are 7 cars per hour produced.